Hi guys, welcome back. We're going to be talking today about lesson 47 in the second edition of the Math 787 book. We are talking today about scientific notation. Scientific notation is a fantastic way to write numbers that are too big or too small to write with regular numbers. Things like, how much does an ant weigh in pounds? Well, that's going to be a really tiny number, right? So we don't want to write like 0.000028 pounds or whatever, right? We use this thing called scientific notation. Another good one is things that are too large to really comfortably write as a giant number. Things like the weight of the earth. That is a good one as scientific notation. So how does scientific notation work? First, before we start on that, you need to know how to deal with our powers of 10. And so we've been talking a lot about things like 2 squared equals 4, or 9 squared equals 81, right? 5 squared equals 25. Basically that we're multiplying this thing 2 times. So we're gonna do the same thing, but we're gonna do powers of 10 today. So with a base 10. So 10 to the second power just means 10 times 10, which we know is 100. 10 to the third power, make sure this is focused, is going to be 10, 1, 2, 3 with 3 zeros. Because it's 10 times 10, which is 100, times another 10, which is 1,000. 10 to the seventh power is going to be 1 with 1, 2, 3, 4, 5, 6, 7 zeros. That's going to be 10 million. So basically, that's all you got to know about those is that little number, that exponent tells us how many zeros we're going to have involved. All right, kids, if you're in my class, you need to be taking notes and writing those notes down. Example number 1. Write 5,206 in expanded notation using the powers of 10. So we know that this is 5,206, right? 5,000. So 5,000 would actually be 5 times 1, actually 10, and let's write it out first this long way. It'd be 5 times 1,000 plus 2 times, and this is in the hundred spot, 2 times 100 plus, and we're going to skip that spot since it's a 0, so it's plus 6 times 1. Okay, so what we have here is we've got 5 times 10 to the 1, 2, 3 spots, so to the third power, plus 2 times 10 to the 1, 2, so the second power here, right? Let's put these in some parentheses so you can see. And then our third one over here is plus 6 times 10 to the 0 power, because there's no zeros right there. And anything to the 0 power is going to be 1. So this is how we would write it in expanded notation using these powers of 10. Guys, this is scientific notation here. This is, and so the key with scientific notation is knowing that this number has to be greater than 1, but less than 10, right? So 0.9, that is not going to work as a scientific notation number. We would have to move our decimal over. And so that's what we're going to talk about is how do we come up with scientific notation by moving decimals. So for example number 2, we are going to do 46 and 235 thousandths times 10 to the second. All right, so guys, you see that this decimal is, that's a decimal, not a comma. That decimal is right here. When we multiply, we make numbers bigger. So what I'm gonna do is I'm gonna be moving this decimal however many times this is, right? Because because we're multiplying by 10, or 1 with 2 zeros, so we're multiplying by 100. So we're gonna move it over 1, 2 spots. So this guy written out would be, and this is called an expanded notation, would be 3.5, 4,623 and 5/10. Okay, so let's practice another one of those. Example number 3, we have multiply 3.14 times 10 to the 4th power. Again, this tells us we're going to be making this number larger, so we're going to be moving, because we multiply to make things larger, 4 times. So we're going to go 3.1, and we're going to do it 4 times. So 1, 2, 3, 4, and we're going to put our decimal here. Throw a 0 here, 0 here. So this guy equals 3, 1, 4, 0, 0. Throw a comma in there so that it makes it a little easier to read. 31,400. Okay, good work. Let's see example number 4. Example 4. This says write 2.5 billion in standard form, billion, in standard form, 2.5 billion. That's gonna be 2,500,000,000. Then we've got the rest of it, okay? And that's our thousands bit, okay? So that's gonna be in standard form like that. Okay, so now that we've done multiplication, we're gonna do division. We divide to make things smaller, right? So for example, number 5, we've got 3.5 divided by 10 to the 4th power. Now, the decimal is right here. And just a friendly reminder, if there is no decimal, it is always at the end. So I'm gonna move this guy down here and it goes to the 4th power. Dividing means we're gonna make the number smaller. So when we were multiplying, we were moving the decimal this way, right? This time we're gonna move the decimal 1, 2, 3, 4, put a decimal here. So this answer is gonna be point, and notice that I've got some spaces here that I need to fill. We're gonna fill those guys up with some zeros. So it's 0.000, 35 hundred thousandths. Is that the right spot? Yeah, okay, so then let's do, okay, at the bottom of page, the practice problems start at the bottom of page 287. I would like you to pause the video, do those practice problems. Guys, this needs to be at the top of your homework. I'm not gonna tell you guys again. So 4A, 4, 5, 6. We're gonna write this as standard, or as scientific notation. So, write each number in, in expanded notation with the powers of 10. It helps if you read the instructions. So this is 400, so we're gonna do 4 times 100 plus 5 times 10 plus 6 times 1. Now we've got to write that in expanded notation as far as the powers of 10 go. That's going to be 4 times 10 to the, there's 2 zeros, so it's going to be a 2, plus 5 times 10 to the, there's 1 0, so that's going to be a 1, plus 6 times 10 to the no zeros, so that's going to be a 0. So that's A. So for B, we have 1,760. 1,760. Okay, I'll skip this part now so that you guys, well, I'll do it one more time. 1 times 1,000, because that's in the 1,000 spot, plus 7 times, and it's in the hundreds spot, so 7 times 100, plus 6 times 10. All right, let's put this into expanded notation or scientific notation, okay? So to the powers of 10, we've got 1 times 10 to the 1, 2, 3 zeros, plus 7 times 10 to the 1, 2 zeros, plus 6 times 10 to the, 10 to the 1 0 here. So it's gonna look like this. All right, guys, let's do C. Oh, now we're getting up there. 186,000, 186,000. So again, we're gonna do 1 times, and that's in the 100 spot, like that, okay? Plus 8 times, and that's in the 10,000 spot. It's gonna be like that. Plus 6, and that's in the 1,000s spot. So times 1,000, just like that. Okay, now let's turn it into scientific notation. Right here we have 1 times 10 to the 1, 2, 3, 4, 5 spot. Plus 8 times 10 to the 1, 2, 3, 4 spot. Plus 6 times 10 to the 1, 2, 3 spot. That is your final answer for C. All right, guys, let's simplify these other ones that are on the next page. D, simplify to 24.25 times 10 to the 3rd. Now we are multiplying, so we're gonna make this number larger. So we're gonna go, so this equals 24.25. We're gonna move this over 3 spots. 1, 2, 3, put my decimal here. So we end up with 24,250. 24,250. 25 times 10 to the 6th. 25 times 10 to the 6th power. Now, this is a case where there's no decimal shown, so it's at the end here. So I'm gonna write 25, and it's to the 6th power. I'm gonna make it larger, so we're gonna go 1, 2, 3, 4, 5, 6, and put a decimal there. Now I got to fill in some zeros here because I need some placeholders. So we end up with 25 with 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6. That gives us 25 million. Let's look at F. Now we're making things smaller. We have 12.5 divided by 10 to the third. 12.5 divided by 10 to the third. That equals, I'm going to do it right down here. 12.5. We're dividing, so we're making the number smaller. We're going to go 1, 2, and 3 right there. So we end up with 0.0125. Good. So that was F. Let's do G. We have 4.8 divided by 10 to the fourth. That means we're going to start with 4.8 and we're making it smaller because we're dividing. And we're going to go over 1, 2, 3, 4, put a decimal, throw in some placeholder zeros there. So we end up with 0, 0, 0, 48, just like that. Okay, for H, find the missing exponent. Oh, this is a good one. 10 to the third times 10 to the fourth equals. Now this is kind of tricky. It's because we have 10, we have 3 tens, right? And then we have 4 more tens. That is 1, 2, 3, 4, 5, 6, 7 tens. So you'll notice that this guy is 7 here. That one, so even though you're multiplying these bases, these guys are called bases, we don't do anything with bases. Notice that stays the same, and we add the top ones. Let's do I. 10 to the 8 divided by 10 squared. This one's different. When we multiply, we add. For this guy, it's like if we said this. We had 1, 2, 3, 4, 5, 6, 7, 8 tens upstairs. And then divided by, we had 2 downstairs. 1 goes away, 1 goes away. 1 goes away, 1 goes away. We are left with 6 here. So this is 10 to the 6th power. So up here, when we're multiplying, we're adding the bases. Down here, when we're dividing, we're subtracting the bases. So keep that, or the exponents, I think I said bases, I'm sorry. Keep that in mind. Okay, so let's write the other ones in standard form. So for J, we have 2.5 million. So that's going to be 2,500,000, and then a bunch of zeros until we get to the end. Okay. 15 billion. So this guy's going to be 15 billion, right? 15 billion, and then we have to do zeros until we get to million. Then we have to do 1, 2, 3 zeros till we get to thousands, and then 1, 2, 3 zeros until we get to our decimal. And then L is 1.6 trillion. So we've got 1,600,000,000,000, and then that's billion, and then we've got million, and we've got thousand, then we've got till the end. Okay, so trillion, billion, got a dog here. Trillion, billion, million, thousands. All right, guys, if you have any questions, let me know. Otherwise, make sure that those are at the top of your homework, and we will see you in class. Thank you.